Hey everyone, we're here for our next session. We have Elena, CEO of Ironfish. She'll be doing a talk on how to develop zero knowledge applications completely in the browser, and I'll let her take it from here.
Cool. Hello. I gave a talk about an hour ago, so some of you might know me. So when I kind of made this presentation, I didn't know exactly how I was going to do it, I'll be honest, but I kind of wanted to drive one point, or like the goal of this presentation is to kind of showcase to people the tools that we have available today to actually develop zero knowledge proofs in the browser, and fairly efficiently so, to make apps that are actually very mature and have a really rich experience, even though the prover for the zero knowledge proof is actually running completely in the browser. So what are zero knowledge proofs? If you've seen my previous presentation, you might have kind of an idea of what they are. If not, here's a link to my slides, and I'll post this presentation also on my Twitter, Lean the Bean, so you can get it from there. So for people who have not been to my previous presentation, zero knowledge proofs are honest computation. So they are a way for you to prove something about data that you don't necessarily need to show. And so they're used for scalability and privacy, but really they're all about proving honest computation, and used for privacy and or scalability, or sometimes both. So there are a lot of types of zero knowledge proofs. Groth16 in 2016 is still kind of the gold standard, so to speak, in terms of its metrics, and it's probably the one that has the most tool sets that I'll showcase today. But there has been so much work happening in zero knowledge proofs without a trusted setup, and I'll go over why that's important kind of through example, really. And so right now we'll just focus on Groth16, primarily because it has really favorable metrics. So its prover is fairly fast, and I'll kind of showcase some of the kind of apps in the wild that kind of really show this. Its proof size is actually very small, which is a kind of a big deal, and it's very favorable when you're thinking about doing apps on Ethereum, for instance, because that means that you can actually fit the proof size in a call to a smart contract. It's fairly small, and so that's actually very favorable. And the verification time is also very fast. It's roughly 10 milliseconds, and it's constant time, which once again is really good for verifying zero knowledge proof apps, especially like if you're thinking about something like on Ethereum. The way you verify proofs is like 3 pairings with 3 points, and so you can actually fit that into a smart contract. And we actually have really a great and mature tool set to support this. So the goal of this talk really is to kind of showcase to you the tools that are available today, so that you can actually build these zero knowledge proof apps, whether it's on Ethereum, or whether or not the verifier lives in Ethereum, or whether or not you decide to set up in a different way. So probably the oldest one is libsnark, and I probably won't go over it as much because in my opinion it's not as user-friendly. But the one that I will go over is something called Socrates. And Socrates has a domain-specific language. So I guess I didn't link this, but the GitHub for it kind of gives you an overview of how the circuits are actually created. And I'll go over that in a moment as well. And then Circum is the other one that I'll probably showcase the most. So Bellman is kind of the one that is maybe used the most, or at least we're using it. It's a pure Rust implementation. It does not have what's called a domain-specific language, and I'll show off what that is, but it does provide a lot of tools to actually create your own circuits. So how do you run Bellman in the browser? There's not really an easy way. You can do it through Wasm, and it is definitely possible. It will take some kind of massaging to get that to work. There is actually a really great project that I found out only recently called ZK Interface by Kedit, and they've been trying to standardize exactly how these proving systems, how they interact, and they actually have kind of a wrapper around all these circuit generators, and it actually does run in the browser, and I'll showcase that in a couple more slides. So Socrates, once again, it is actually a domain-specific language, meaning that you can actually write in the pseudocode, and it'll generate circuits and witnesses and generate verified proofs. What's really cool about Socrates is that it actually exports or generates a Solidity smart contract verifier that you can actually deploy on Ethereum. So to kind of showcase what I mean by domain-specific language, the way you would write circuits, for instance, this is a Sudoku format, so a Sudoku puzzle. So the way you would, for instance, validate a Sudoku puzzle is kind of like the pseudocode language of actually figuring out what you want to check, and you have private and public bits to actually make the witness. And by that I mean there are certain fields that you will use to generate the proof that you want to keep private, and there are certain fields that are public that you will then use to actually validate the proof. So those public variables you would either give with a proof, or maybe they're publicly known, etc. So how do you run Socrates in the browser? Once again, because it is Rust-based, you can actually run it in Wasm. I'm not entirely sure if anyone has tried to run Socrates entirely in Wasm, but if someone has, I would love to hear from you. However, ZK interface actually does support Socrates as well. So you can definitely use that. So the one that I'm probably like the most excited about is Item 3's tool set, and they have something called Circum. Actually, it's a family of tools, and what's really exciting is that they actually made it in Wasm, so it runs fully in the browser and yet has really, really great times in terms of performance. And they have a really great tutorial to kind of explain how they do it. So for you to build a circuit, once again, it's actually very straightforward. This is like a pseudo language that you would use to actually make your circuit. And you can compile your circuit, and it's actually a JavaScript implementation. So you can have this entire thing run in browser. So you can have the prover run in browser. And I can't stress how cool this is, because I remember giving kind of a similar presentation only 9 months ago, and this was definitely not as easy as it is today. So I highly recommend looking into their tutorial and their tool set, primarily because they have really good performance speeds. And I'll showcase kind of an app in the wild that uses Circum and how fast it feels. So the overview when you're using any of these tool sets is kind of the same way. And here I'll kind of showcase why it's really important for the resources going on to not have a trusted setup. So first step is you create your circuit, your program. So kind of like I was showing with the Sudoku puzzle or with Circum's tutorial, you kind of write in the pseudo language if it's a domain-specific language, or something like Bellman, you would kind of figure out your circuit. And you basically write a program of what exactly you want to prove. And then for ZK Sonics in particular, you do need a trusted setup. Now, the trusted setup creates verification keys that actually, you would need for the verifier to actually take in your proof and use those verification keys to validate it. So in order to generate a proof, you create what's called a witness. A witness is basically a terminology saying that you give it sort of like the plain text answer, so to speak, for how you would want to prove it. So witness has both private inputs that you want to hide and public inputs that you want to verify against. So basically all the juice, so to speak, in order for you to generate that proof. And then to verify a proof, you would use the verification key that you created from the trusted setup, and you would use that with the proof and the public inputs to actually verify it. So the cool thing about something like Socrates or Circum is that they kind of automatically generate for you the Solidity verifier contracts. So you can have some really rich experiences, for instance, claiming something without revealing what it is. So for gaming, this is actually really cool because so far on Ethereum, the only games that were really kind of accessible are ones that have like a full open view. So like CryptoKitties, everybody knows like who owns what. But you can do something like Battleship where you have kind of like hidden state because Ethereum is transparent and so the state is public. And so if you're trying to create games with like hidden state, it becomes kind of challenging. And what's cool about zero knowledge proofs now is you can actually claim some statement, maybe like that you've verified things correctly or computed things correctly, or if someone is playing Battleship and you say like, okay, you missed my ship, you can actually have a proof that says I'm not lying. you actually did miss my ship. So here's kind of where I really want to showcase why snarks kind of are a problem, or at least can be. Every time you change your program, so to speak, you actually do have to redo this trusted setup. And so that does become challenging. However, we do have a lot of tools, and Circum actually does provide one, Snark.js, that kind of streamlines the whole MPC process. So MPC is multi-party computation. So the idea there is you can actually invite a lot of people from all around the world to kind of contribute to the randomness, to have that trusted setup such that if only one person is honest, then the entire thing is honest. And I think it's actually kind of a great way for your projects to even bootstrap, because it's kind of like a pre-release. You're saying, okay, like if I'm launching a game, then I can have my future users contribute to the soundness of the entire thing. So when I was doing this or similar presentation quite a while ago, I did have a demo because there wasn't anything available at the time that kind of showed what I wanted to show. But today we actually have a lot of demos. And so I'm going to showcase some other work. So ZK Interface is made by Kedit, and they have a really great demo for how you run everything in the browser, which is kind of amazing. So here they're using bulletproofs. So the one thing you're not going to see is the creation of the trusted setup, but you kind of get to witness the entire step process. So kind of like, as I was saying before, you first start with a program. You kind of generate in whatever pseudo language or not what you want to prove. You compute a witness, meaning that like what are basically all the ingredients that I'm giving to generate the proof, even the private ones. You generate constraints. And finally, you verify the proof. Oops, generate the proof and verify the proof. Need to prove, okay. Not entirely sure what happened there. There you go. Cool. So ZK Interface is really great. It, as I was saying earlier, it doesn't do just bulletproofs, it does Groth16 as well. So please check it out. I haven't checked it out myself in terms of production, but this is really cool. So the one example that I really want to showcase is Dark Forest. I don't know how familiar you guys are with it. So this was created not by me, by someone on Twitter, or BGU33. And they actually use Circum. So Dark Forest is fully open source, so you can go check it out yourself. You can even run it locally, although that you will have to, there is some problems running locally. However, I can show you how it looks like in production. So this is using Circum. The verifier for Dark Forest is on Ethereum, so it's like actually on chain. And what happens here is, so the premise of Dark Forest is that you're trying to claim planets without letting other people know that you've claimed those planets, because maybe if they know that you've claimed these planets, then they will try and kill you or something. And so you're really trying to like claim planets without other people knowing the location of the planet. And so the way you do that is with a zero knowledge proof. So the way Dark Forest works is you actually mine, quote unquote, the map. So you hash the coordinates, and if the hash is below a certain threshold, then you found a planet and you can claim it. And so the zero knowledge proof really is, there is a certain coordinate, and I know the hash of it, and the hash of it is equals to a planet effectively. So to kind of give you a feel of how it works, or how it feels in terms of speed, it feels pretty good. So let's see, I'm going to try and claim this planet. So here on the right, it actually is calculating witness and the proof, and it's done. And that's the user experience. Now, okay, there's some error, but the start that happened in the browser already happened, which is great. Cool. So for something like Dark Forest, it is a fairly simple proof. So I'm not entirely sure how many gates it has for this particular proof, but it is fairly small. However, this is a really great user experience. And so really the point of my presentation is I want to see more Dark Forest out in the world. This is a really cool kind of application where you can actually have a lot of creativity of something like using Ethereum, where before it was completely transparent, and now you can actually make tools that are very user-friendly. Because before, obviously, this was actually all possible It's just that it was really hard to make it work in the browser. And now that we actually do have the capability of making it in the browser, then all of a sudden you can start thinking about all these like applications that are very user friendly that people can onboard really quickly. So I'll kind of pause there, and really I wanted just to take the time to answer questions because hopefully people are interested in this. Like I said, I really want to see people get creative with these things because we have so many really, really mature tools that allow you to do quite a lot. And there's this kind of like myth, for instance, that if it's in the browser, then it's slower. And that's actually not the case anymore. It's pretty fast. It's pretty seamless and allows for a pretty great user experience. Cool. So I will kind of pause here so I can look at some of the questions, if there are any. Are there any questions? Are there really zero questions? Or nope. Huh. I guess people have no questions. Well then.
All right, guys. Any questions?
Oh, the question that I got was how complicated it is to train Solidity devs to develop circuits. So if you look at Circum or even Socrates, they do provide a domain-specific language. So they actually make it very easy for someone to write these smart contracts. So it shouldn't be hard at all. And like I said, like for Socrates and for Circum, they actually have really great tutorials that are pretty clear. And actually both of them also have gadgets. So for instance, something like verifying a pre-image of a hash, there's a ton of tools that you can just kind of use, so to speak, without having to, remake the circuit for like a SHA-256, for instance. I think or an MIMC. So Dark Forest, for instance, the hashes that they use, I believe, are MIMC or Mimic, or however you pronounce that. So there's actually like gadgets for that. I think on both actually at this point. So yeah, it should be honestly pretty straightforward. And then I'm looking at kind of more questions or more comments. Can we do chess? Yes, and I think Daira totally answered the question correctly. Chess is open state, so chess is definitely something you can do in Ethereum today. The problem comes when you want to do things that have a closed state. So for instance, poker has a closed state. You can't know other people's cards. And so for instance, if you say, okay, well, I have like a flush, for instance, you can actually prove that with a zero-knowledge proof and not necessarily show it. Although I guess shuffling here would be like the more appropriate example. Cool.
Awesome. So if we're done with questions, we can take a short break before our next session. Do you have any closing thoughts, Elena?
Oh, just that it's actually fairly easy to do these programs now. And the performance in browser is actually like near native. So do not be afraid of making browser-based zero-knowledge proof apps.
Awesome. Cool. Thanks, Elena. All right, short break. Next talk will be on private liquidity pools for perpetual